Section 4.6, using more than one pair of congruent triangles. Sometimes two triangles that you want to prove congruent have common parts with two other triangles that you can easily prove congruent. You may then be able to use corresponding parts of these other triangles to prove the original triangles congruent. Here's what I mean. Take a look at this diagram. You're given that angle 1 is congruent to angle 2, and angle 5 is congruent to angle 6. You're trying to prove that AC is perpendicular to BD. In order to prove that these two lines are perpendicular, you would have to prove that angle 3 and angle 4 are both right angles to make the perpendicular lines. So let's see how you can do that. We start off with the given, as always. Angle 1 and angle 2 are congruent. Angle 5 is congruent to angle 6. We also know that AC is congruent to AC by the reflexive property. This now gives us two angles and a side. So we can say that triangle ABC is congruent to triangle ADC by the ASA postulate. Knowing that, we can now start using some corresponding parts that are already congruent. We're trying to get the triangle ABD, this triangle that's split into two. We want to prove that those two little triangles are congruent to each other and allowing us to get 3 and 4 congruent, and so forth. So therefore, we know that AB and AD are congruent by CPCTC. Next, we know that AO is congruent to itself by the reflexive property. Then we can say that triangle ABO and ADO are congruent to each other by the side angle side postulate. Next, angle 3 and angle 4 are congruent because of CPCTC. And lastly, if two lines form congruent adjacent angles, then the lines are perpendicular, and AC is perpendicular to BD. As you can see, we proved two triangles congruent. In order to be able to prove two different triangles congruent by using corresponding sides. Let's try another. You're given that RT and RV are congruent to each other, and NT and NV are congruent to each other. So I'm going to mark up the picture first so that you can see which we're talking about. And what we're trying to prove eventually is that TS, this side, and VS, this side, are congruent to each other. So let's start with the two triangles that we have that are to the left. Again, using the given. Next, I know that from R to N, it's congruent to itself because of the reflexive property. This now gives me the three sides, and RTN and RVN are congruent to each other by side-side-side postulate. Now, angle 1 and angle 2 are congruent to each other because of CPCTC. If we say that RS is congruent to RS because of reflexive property, we now have this short side and this short side, angles 1 and angle 2 being congruent, and RS congruent to itself because of the reflexive property. So we can say that triangle RTS and triangle RVS are congruent to each other by side angle side. Then this allows us to say that TS is congruent to VS because of CPCTC. As you can see, knowing how to prove one pair of triangles congruent can lead to a whole bunch of other kind of proofs with corresponding parts.